All right, you watching this video, this is what we are doing today. We are solving linear equations. This is actually an old Smart Notebook, so it should have a 4 up front here. This is our 4th lesson. We're solving several different kinds today, so this lesson might seem a little bit busy. So what I've done, because we have less time this year than we have in the past, I have changed one of the notes practice problems, and I have removed several of the homework problems to simplify things, but still be sure that we hit all of the skills that we're going to hit. And those skills are just solving general linear equations, which these steps on this slide, there's 1, 2, 3, and then on the next part of your notes, there's 2 more steps. These 1 through 5 steps are just general solving linear equations. And then the next slide, if you have your notes printed, this is the bottom left of your notes. This section is sort of like leveling up a little bit. One sort of level up is if we have fractions in our equation, and the other level up is if there are decimals. And so we'll talk about a trick for each of the, not a trick, but a technique to make those simpler to solve. And then this is our first example. So it might feel like I skipped over all those words, but I'm going to talk about all of that stuff as I'm teaching you the problems, all right? So what I'd like for you to do before I start this problem is I want you to go read the first step that's on the upper left part of your notes, which by the way is right here. This first step, read that to yourself. It says to distribute to eliminate parentheses. So if I go back to this example, I want you to find the parentheses in the problem and ask yourself what's being distributed outside those parentheses. It's a negative symbol, right? You can think of that also as being a -1. And so I'm going to use this notation to show the first step of the distributive property. S1 for step 1. And what I'm distributing is this -1 right here. Everything else I'm just going to leave the same for this step. So I'm just going to bring all the other stuff down as is. So on the left side, that would mean -12 minus 5w. And on the right, bringing down the -9. Distributing that -1 gives me -6w. Please always remember that whatever you're distributing goes to both terms inside the parentheses. So it's also -1 times +7, which is -7. Now take a second and go back and read step 2. Probably already read step 2 while I'm fiddling around with my tools. Okay, combine like terms on each side. So let's go back to that problem. Step 2. On the left side of the equation, there are no like terms. So we're going to bring everything down and leave it the same. And what are like terms on the right-hand side? The -9 and the -7, right? And nothing combines with the W term. Baby girl, I'm making a video, okay? But you can stay in here. Just know that I'm recording. Watch out for my star. I love you. All right, so let's go back to step 3. See what that says. So right here, move variables to one side and constant to the other by adding or subtracting, and then combine like terms. So we're going to do that. So I'm going to go back to my problem. It does not matter if you're moving the w's to one side and the constant to the other, or vice versa. So what I'm going to do is I like to move the variable to whichever side will make it have a positive coefficient in front. That's absolutely not necessary. I just like to. So in this case, what that would look like is moving the 6W that's on the right and doing the opposite of it to both sides so that it moves over to the left. So that would mean adding 6W to both sides. So by doing that, the W's cancel out on the right. And basically that means I've moved the W to the left. And if I've moved the W to the left, I have to move any constants on the left over to the right. So the constant on the left is the -12. I'm going to move it over by doing the opposite of it to both sides. So it cancels out here. Step 3. And now on the left-hand side, I have -5W plus 6W is just a positive 1W. And -16 plus 12 is -4. And step 4, if you look at that real fast, says to multiply or divide by your coefficient to isolate your variable. We don't have to do that because our variable ended up just being W. What this step is for is if I ended up, instead of W equals -4, if I had ended up with like 5W equals -4. The coefficient is 5. So that's what, when this word says coefficient, that's what it's talking about. And to keep solving, I would have had to divide by 5. And the last optional step is check your solution by substituting it into the original equation. That's a very wise thing to do, but we're not gonna, just to save some time, but you are welcome to do that on your own time. And then we box our answer. Right? So what I'd like for you to do is pause the video and try this next problem all on your phone. All right, so step 1 is to distribute, and there are 2 distributives here. So you should have distributed a 6 on the left. Be sure to distribute it to the second term. Raise your hand if you did that. Actually, don't raise your hand. You're all by yourself somewhere. You might look funny. But this is me we're talking about. I really don't care how funny I look sometimes. Okay, so distributing that through gives you 6n minus 72. And on the right, 4n, distribute the 4 to the 8. That gives you 32. And then minus 2. All right. Step 2. It says to combine like terms on both sides. So on the left, nothing combines. So we just bring it down as is. And on the right, the 32 and the -2 combine. But there's no one to combine with the 4n, so it just stays like that. All right. So there's step 2 done. Step 3, move the variables to one side and the constants to the other. So I'm going, and it doesn't matter, again, you can put the n's on the right or the n's on the left, whichever. I'm going to move the n's, the variables, from the right to the left. So that means moving 4n over by doing the opposite, which is subtracting. And so if I move the n's to the left, I need to take the constant on the left, which is -72, and move it to the right by doing the opposite. And that will lead me to n on the left because the 72's cancel. And 102 on the right because the 4n's cancel. And this is where step 4 comes in, to divide by the coefficient. And n equals 51. So one thing, oh, I wanted you to write something down. These 2 examples we did are like these two homework, or three homework numbers, 7, 9, and 11. I want you to do those three problems that are like those two examples that I just gave you. All right, so that is the first category of linear equations we're going to talk about. Going back to the earlier slide here, let's go next to the decimal kind of problems. That's what we're going to be doing now. And right here it says if you have decimals, multiply the entire equation by the multiple of 10 necessary to eliminate them before starting to solve, right? So chances are good you stopped listening to me talk right around the time I got to here. You were just like, I don't know what she's talking about. Here's what I mean. If I have a number with a decimal like 4.5, there is one decimal place, right? So if I were to multiply that by 10, I would get 45. Notice there's no more decimal. Similarly, if I had two decimal places, like if I had 4.56 and I multiplied it by 100, two zeros, 1 0 for each decimal place, I would have 456, right? I would have no more decimal. And that is what this tip means. Multiply by the multiple of 10 necessary to eliminate your decimals. Going then to the example in your notes, let's decide what multiple of 10 we would need to get rid of the decimal in that problem. So look at these decimals for a second. Find the one with the most decimal places, and that's how many zeros we'll need on the one to make 10 or 100 or whatever we need to get rid of the decimals. You should have noticed all the numbers have the same decimal places, and they all have just a 1 decimal place. So that means if we multiply everything by 10, we'll get rid of all the decimals. I'm going to, we could do that right now. But what I'm going to suggest you do, because I found for most students, this works more, this is more intuitive than the way I like to do it. We're going to distribute first to get rid of the parentheses. So we're still going to stay with the same step 1 as the last time. So that's a negative out front that I'm going to distribute through. So I'm not doing any multiplying by 10s just. There's actually several ways to approach this problem. I'm just doing one that I find works best with how students usually do it. It's not really my preferred way, and that's okay. So now that I've distributed and got rid of the parentheses, here's where I'm going to take a little break from the steps. I'm going to do my multiply by 10. Now remember, because an equation is balanced, what you do to one side, you have to do to the other, and if you're multiplying by 10, every single thing has to get multiplied by 10, every little piece. And so every single decimal you see is going to be moved over one spot because everything's getting multiplied by 10. So here's what that would give us. 79 minus 26W equals 15W minus 91 minus 21W. Now you notice we have no more decimals, and some people like to work like that with no decimals. Some people are comfortable with decimals, others are less comfortable, and so this is a way to get rid of them if you so choose. And now we go back to our step 2 where we combine like terms on each side. So on the left side, again, sensing. There are no like terms. On the right side, we can combine the terms with the W. So 15W minus 20W is negative 6W. Then we have the minus 91. Step 3 is moving the variables to one side and constants to the other. So what I'm going to do is move the W from the left to the right by doing the opposite, which is plus 26W. And since I moved the W's to the right, I move the constants to the left. That means moving negative 91 to the left by doing the opposite, which is plus 91. And that gives me 20W on the right and 170 on the left. And then step 4 is to divide by the coefficient. And 170 divided by 20 is 8.5. And so that's just one way you could have done the steps. Some other ways you could have performed this problem is multiply everything by 10 before you even started. That is a little bit tricky when you get to the parentheses because you would have to know to distribute the 10 inside the parentheses. You could also have combined like terms in step 1 before you multiplied by 10. So I could have done multiplied by 10 step here instead of where I did. So there's different ways you could have done it. This is just a way that I chose to show you. And this example problem is like homework number 25. All right, so that brings us to our last kind of equation, which is with fractions. So if we go back to this part of the notes, the tip for working with fractions in equations is to multiply the entire equation by the LCD to eliminate the fractions before starting to solve. So if you remember what LCD stands for, it's the least common denominator. And denominator is the number in the bottom of the fraction. And this is a longer equation that we usually do every year, but because we are short on time this year and I wanted to simplify this lesson, we're actually going to rewrite this equation. So scratch this part out of your notes. So we're going to do a mini version of that equation. Plus I changed the variable away from the lowercase q because it's awkward to write in an equation. So we're going to use m instead. So m over 6 plus 1 equals 2 plus m over 8. And a common way to work with equations that have this fractions is to clear the denominators by multiplying by the least common denominator. And the LCD means the smallest, so let's look at that word, least common denominator. The least part means the smallest. The smallest number that they both have in common, that's the C part, that both the denominators have in common. As far as they go into that are multiples of 6 and 8. So I want you to, for a second, let me just build this up. Let me go back a little bit. imagine for a second that the m over 8, okay, let me even go a little bit simpler. Imagine this is the equation that I had, m over 6 equals 2. In order to solve for m, you would multiply both sides by 6, right? Because that would cancel out, and you would get m equals 12. The problem with this equation, if I were to try and do that, multiply everything by 6, that would be a good start, but it would not, when I got to this fraction, it would not cancel the 8 out in the bottom, and then I'd still have a fraction with a denominator. So what we need is one number that will cancel the 6 out and cancel the 8 out at the same time. So we need a multiple of 6 and 8. Or in other words, a number that 6 goes into and that 8 goes into. So pick one of them and just start thinking of multiples. Like if I'm going to start with 8. Multiples of 8 are, multiples of 8. We have 8, but 6 does not go into 8. So that won't cancel both of them. 8 times 2, my next multiple is 16. If I multiplied everything by 16, the 8 would cancel, but the 6 would not. The next multiple of 8 is 24. And notice that 8 goes into 24 and 6 also does. So what I'm going to do is multiply everything by 24. This is my least common denominator. And you'll notice this is a distributive property. So it's kind of like my step 1 all over again, but just in a different way. So because it's an equation, whatever you do to one thing has to be done to everything. So everything's getting multiplied by this 24. Now, when you do 24 times m over 6, it's 24m over 6 like that, because it's really 24 over 1. And when you multiply fractions, you multiply across the top and you multiply across the bottom. So it's 24m over 6, and 24 divided by 6 is 4. So when you distribute 24 into that first term, you end up with 4m. When you distribute it to the plus 1, you get plus 24. Distributing it to the 2 gives me 48. And when I distribute it all the way over there to the m over 8, you've got 24 over 1 times m over 8. You're multiplying the numerators, which is 24m, and the denominators, which is 1 times 8. And 24 divided by 8 is 3. That gives me 3m. And that's the mini part of this tip. Because now look at your equation. What do you notice? Hopefully, that there are no more fractions. So now we just work it normal. We go to the step 2, which was combining like terms on each side, but we don't have to do that. There's nothing to combine. So we move on to step 3, which was moving the variables to one side and the constants to the other. So that's, for me, that's going to look like subtracting m to both sides to move the m from the right to the left, and then subtracting 24 to both sides to move that from the left to the right. So that will give me m equals 24. And then I don't have to do step 4 because there's nothing to divide by. And this example is going to be like homework number 17, 21, 27. So the only homework problems I want you to do are the ones I've mentioned in each of these problems. So let me go back and make sure. I want you to do 17, 21, and 27. And then I want you to do number 25. And I want you to do 7, 9, and 11. And the rest of them you can omit. However, on the key, I still have the answers to them just in case you want to know, in case you wanted to work them and wanted the answers.